Hello everyone. Welcome to our lesson on radicals. I'm Teacher Bob, and today we're going to explore how to simplify radical expressions and perform operations with them. I promise to make this as fun and engaging as possible, so let's get started. All right, let's dive into radicals. A radical is a symbol that represents the root of a number. And this is what the symbol looks like. The most common root is probably the square root symbol. And simplifying radicals means just reducing them to their simplest forms. Okay, let's start with some key concepts. The square root of a number is the value that when multiplied by itself gives the original number. For example, the square root of 9, we'll just put a 9 under this root symbol. And if there's no number out here, this is assumed to be a square root symbol. Okay, so the square root of 9 is 3 because 3 times 3 is equal to 9. When simplifying, we look for perfect squares. For instance, the square root of 18 can be simplified to 3 times the square root of 2. Let's write this out here and make this a little bit more clear. Okay, so the square root of 18, we can break this down into the square root of 2 times the square root of 9. 2 times 9 is equal to 18. And we're looking to reduce this or break this down into a whole number part. We're looking for a perfect square, one that has a square root that is an integer. 9 does. 3, as we see above here, the square root of 9 is 3. So this can be broken down into 3. So we can rewrite the square root of 18 as we want to put the integer at the front, so it's going to be 3 in place of the square root of 9. And the square root of 2, well, that's just going to remain the square root of 2. We cannot simplify that. So the square root of 18 is equal to 3 times the square root of 2. Let's simplify the square root of 25. Pardon me. We're going to make this the square root of 50. So we're looking for a perfect square, a number we can take a square root of when we're breaking this down, and it needs to be a factor of 50 as well. Well, 2 times 25 would work because we can take the square root of 25, and that gives us an integer or a whole number. So square root of 2 multiplying the square root of 25 gives us the square root of 50. And we can further break down the square root of 25 to 5. 5 times 5 is equal to 25. We can't do anything with the square root of 2. So the simplified form of the square root of 50 becomes 5 times the square root of 2. Okay, I want to talk about the different parts of and their proper names for a root symbol and the number that is underneath it. If we had a number, let's say 2 times 2 times 2 is 8, And we wanted to calculate the cube root, or the third root of 8. And that means we want a number that we can multiply by itself 3 times. That's what this number up here tells us. The cube root, or the third root, would be 2. Remember, this is the root symbol. This number here is called the index, and the number we're applying this level or index of a root to is called the radicand. And of course the 2 is going to be our answer. It's going to be in this case, the third root. And as I mentioned, if you just see the root symbol with no index attached to it or written here, we assume that it's a square root. Okay, so that's the different parts of it, and we've talked about simplifying it. So let's do an operation with roots. So let me go to another page here. All right, let's try the square root of 18 plus the square root of 8. Now, if we're adding or subtracting, we need to make sure that the indexes are the same and the radicands are the same in order to do our operations. So you can only combine radicals if they have the same index and the same radicand. So we have to break these down. So let's break down the square root of 18 to, well, square root of 2 times the square root of 9 plus, we can break down 8 into, well, I know 2 times 4 is equal to 8, and 4 is a perfect square, so the square root of 2 times the square root of 4. So this square root of 2 times the square root of 9 we can rewrite as 3 times the square root of 2 plus the second one here. The square root of 4 is 2, so that's 2 times the square root of 2. So how many square roots of 2 do we have? Well, in the first term here we've got 3 of them. In the second term we've got 2 of them. 3 times the square root of 2 plus 2 times the square root of 2. They're square roots. They have the same radicand, so we can combine these. So our answer is 5 times the square root of 2. Excuse me. Okay, now it's your turn. Here's some practice questions. Pause the video, solve them on your own, and then resume the video to check your answers. So do that now, and we'll see you when you're ready. All right, welcome back. So question 1 is asking us to simplify the square root of 32. So I'm going to just change my pen to black here, just to show my work here has a different color than the questions. So we want to break down 32 into 2 factors, and one of them needs to be a perfect square. So I can see that we can go 2 times 16. 16 is a perfect square. So the square root of 2 times the square root of 16 is equal to the square root of 32. And the square root of 16, well, that's 4 times 4 is 16, so we can take that square root and just call it 4. And as usual, the square root of 2 we can't do anything with, so we just leave it as a square root of 2. So our simplified form of the square root of 32 is 4 times the square root of 2. Okay, the next one, let's simplify the square root of 72. Well, that can be the square root of 2 times the square root of half of 72 is 36, and 36 is a perfect square. 2 times 36 is 72. So this, we're going to put the integer at the front of our simplified form. So 6 times 6 is 36, so it's going to be 6 times the square root of 2. Okay, next question, number 3. We're asked to combine or add the square root of 5 plus the square root of 20. We need both of these to have the same radicand and the same index. Well, they have the same index. They're both square roots, so that part's okay. We can't do anything with the 5. We can't break that down. What can we do with the 20? Well, I can see that the square root of 20 can be broken down into this radicand of 5, and it just happens that 4 times 5, 4, which is a perfect square, times the square root of 5 is equal to the square root of 20. And we can further break down that square root of 4, can't we, to 2. So we end up with 2 times the square root of 5 for the square root of 20. So now we can add those because we've got the same index and the same radicand. So let's rewrite that. So we have the square root of 5 plus 2 times the square root of 5. Our answer is 3 times the square root of 5. Simple as that. Okay, and one last question here. This is not addition, but subtraction. And we need to break down that our 2 square roots here. They each have the same index. They're both square roots. Let's break down the square root of 98. Well, let's start off with the square root of 2 times, and this works out well, the square root of 49. So 2 times 49 is 98. So the square root of 49 is 7. 7 times the square root of 2. And we already have done the square root of 50 from before, and we know that to be 5 times the square root of 2 if you check one of the previous questions that we did. So let's rewrite this now that we have the same index and the same radicand. So square root of 98 is equal to 7 times the square root of 2, subtract, and we know that the square root of 50 is 5 times the square root of 2. So we've got 7 square roots of 2, subtract 5 square roots of 2. That gives us 2 square roots of 2. 2 times the square root of 2. All right, that's a wrap. Great work, everyone. If you're having problems with any of the material that we've covered, take another look at the video. Try your best with the worksheet questions, and if you're still having trouble, get in touch with me and I'll be happy to give you a helping hand. Be as specific as you can be with your questions to me so that I'll know how to best help you. Remember, math is a journey, and Teacher Bob will be with you every step of the way. See you in the next lesson. Bye for now.